In this video, we'll talk about how to introduce interactions among dummy variables. And we will run with the same example that you saw before, where we wanted to assess or examine the effects of gender and marital status on wages, right? So we had an equation with log wage, and then we had constructed four different mutually exclusive groups: single male, single female, married male, and married female. But now I'm going to tell you that we can achieve the same thing if we had interacted female and married. And you might say, well, this seems easier than constructing those four categories. But the idea is that, when you're doing econometrics or learning this type of a toolbox, you want to understand everything and how everything works and how you can get to the same thing by using different tools. So let's take a look at this regression here that has log wage on the left hand side, and what we have on the right hand side, which is different than what we had before, is this category female or this variable female, which takes the value of 1 if the person is female, 0 for males. Married, this takes the value of 1 if an individual is married, 0 if the person is single. So both of these take only two different values, and then we've introduced this interaction term in our regression. And then we have a bunch of other controls here that I haven't specified, but these are education, experience, and tenure variables. Now let's say we were interested in, looking at the differences between the same four categories, right? So earlier we said we were interested in looking at single males. There were four categories: married women or married females, single females, and married males. Okay, so let's say we wanted to look at the effect. So this is really not an equal to, but we're looking at what is log wage and what is the difference, right? So holding everything else constant, we're going to basically plug in the correct values of zeros and ones to get to our answer. So for single males, notice because this person is single and this person is a male, female would take the value of 0. Married would take the value of 0, and so would the interaction term, right? So this would all be 0. And so we're left with basically 0.321. Okay. For the next group, which is married female, let's plug in the correct zeros and ones here. So this person is female, so this will be 1, is married, so this is going to be 1, and this is 1 times 1. Right, so we basically get 0.321 minus 0.110 plus 0.213 minus 0.301. Okay, and this is going to be equal to 0.123. And for single females, we're going to again plug in the numbers here. For single females, female will be 1. Married is going to take the value of 0. This is 1 times 0. So we're going to be left with 0.321 minus 0.110, which is equal to 0.211. And finally, for married males, this number is going to be 0.321. Let's plug in the right set of zeros and ones. Married males, so female is going to take the value of 0, married 1, 0, 1, right? So we're left with 0.321 minus plus 0.213, which equals 0.534. Right? So from this, we can then assess the differences. And notice that the coefficient on well, let's just take a look at what we're getting here. So this is all that's on this slide is something we've already computed. But basically, the advantage of using this type of an equation with an interaction term is that it allows us to read off the difference in the marriage premium between women and men. So if you were to think about what is the marriage premium for men, that is equal to 0.213, right? So if you look at the difference between single males and married males, for instance, difference between single and married males is basically this right here, 0.213, right? And so we can read off that difference directly from the regression here, okay? And similarly, the difference in the marriage premium is 0.301, right? So here we can see in our regression, the marriage premium is equal to 0.301, and the marriage premium for women is the difference between these two, which is negative 0.088. Okay, so we can get to the same results using this.